Hello everyone, welcome back to another video. Today, thank you for watching this premiere. We're going to be talking about the models, especially the GFS model going crazy for a severe weather event and winter weather event in the long range. This is mainly the GFS, and it's for medium to long range, actually. There's some indications from other models, but then again, take this video with a grain of salt. We're going to be starting with winter weather, actually, and then going to severe weather, which the severe weather portion will likely be longer. So we're mainly going to be looking at the GFS, like I said, but we will also be looking at other models a bit. So without further ado, let's get started. So first of all, we're looking at the reflectivity here, and we're going to mainly be looking at the 25th, where we do have a big system that comes through, lots of snow, and even a severe weather event it is showing. Again, take this with a grain of salt. So we're not talking about this 22nd system. Or the January 22nd system. We're talking about the system that comes through around the 24th and leaves fully by the 27th. And then this system that comes around on the 31st. No, we're not talking about that. So let's start with wind gusts just to see if they're could be just gusty winds for a lot of areas. Damaging winds are separate from this wind gust parameter. So damaging winds like severe potential, yeah, that is separate. So basically, we're going to be showing you this here. We see that the 25th system, it brings pretty good wind gusts, about 48, 43 tropical storm force wind gusts possible for much of the region. So yeah, that's just regular wind gusts along potentially with that winter weather, which, like I said, we are going to be starting with. So let's get to that the snowfall right now. So, of course, total snowfall Kachira is what we look at. It is a better ratio due to the fact that it takes temperature more into account, like I said yesterday. So if we look here for we already have a lot of snow on the ground, well, from the other system, but we do see a lot of snow falling, so we better get closer so we can actually see how much snow from this system specifically. So while this loads, we'll just let it load for a second, and then, sorry about that, by the way, guys. Okay, there we go. So now, yeah, we already see about widespread 6 inches of snow on the ground, and then this other system comes through, brings up to 15 inches. Okay, so this system drops more snow. For example, Michigan snow amount to go from 16 to 26, so we have about 10 inches of snow there. Here, 7 inches to 23 inches, so over a foot. Down here, we see around a foot of snow on the ground. So we could be this system showing widespread 6 inches of snow, and even widespread a foot of snow, and maybe even some runs show widespread of up to 2 inches of snow at the end, but that is pretty unlikely. If we look at the snow depths just to see how much snow will already be on the ground while this storm comes through. And by the way, if I'm stopping my speech a lot, it's because a lot of this is taking a bit to load, which I'm very sorry about, so I'm trying to extend the conversation station, so that's why I'm pausing. Anyway, as the system comes through, there's already around, for the main parts, already up to 4 inches of snow on the ground, but of course, a lot of this snow has already gone away. And we're going to be looking at total ice for a second, so I will just wait for that to load here. Here, yeah, not too much freezing rain, up to 0.25 inches. And that was ice. For freezing rain, up to half an inch to a quarter of an inch, it seems. So yeah. Sorry about the pause there. So now we're going to go back and we're going to go to the Canadian model, GDPS, which we are not going to be looking at freezing. Well, I guess we can. So yeah, they show up to half an inch of freezing rain. And and up to a half an inch of ice. We're not going to be looking at snow depths anymore because that was just a little extra thing there. It's not really an important thing too much. And we're not going to be looking at the 10-1 inch ice ratio. We're only going to be looking at the Kachira ratio. There's no need to look at two ratios. It's pretty much the same thing for the most part. But yeah, CMC shows much less snow in this second system. But yeah. ECMWF high res, which we have to, 12Z. We're not going to look at ice or freezing rain anymore. Looking beforehand, the models are pretty consistent on half an inch. So, yeah, ECMWF, again, doesn't show as much, 5 inches maybe, but yeah, they don't really show a lot for this event, winter event. Only the GFS really does. But let's go to the southeast for a second, where we now could be looking at a big severe weather event. So let's start with dew points, which are one of the important things when it comes to severe weather. And we're actually going to be going to nationwide because this is a big thing, not just for the southeast. So, yeah, anyway, sorry. Let's go to dew points. Dew point. There we go. Being a little more chill here because it's premiere. But 60s, okay, 55 dew point at least, and 50s dew points in general really are the borderline severe weather, usually not, but it definitely can happen at lower. But we're mainly looking at the dew points of 60s. We're not really going to be seeing 70s and 80s dew points, which are really helpful, though. But we're mainly going to be looking for areas with those 60s dew points. And sorry for that background noise, just Aaron. That's my brother. Sorry about that. But anyway, we see for this 25th event, we do see dew points of, sorry if you keep hearing my brother, sorry. But dew points of up to 60 for much of the southeast, and a little bit up into Indiana, but not too much. But yeah, we do see these widespread 60s dew points for a lot of Florida, etc. Those 70s and 80s dew points definitely really stay out in the Gulf. And we see some more dew points build up there, but yeah, we do definitely see these dew points of the 60s go very north, which is definitely going to help. And just there's a lot of these areas even close to the coast, 60 dew points help. Anyway, enough of that about dew points. We are now going to go to the 500 MB wind height, which is basically the trough and shows us the highest 500 MB winds. They help with tornadoes a lot. But of course, you still need other factors. But this can give us a general idea of where the worst will be. So yeah, we definitely see Arkansas, Louisiana, combined with those dew points and these 500 MB winds height really help with the severe weather, up to 110, 115 knots, which that's a pretty strong trough. So definitely we have to watch out for that there. Next, we are going to go to Mosin Staple Cape, which, there you go. That's what it means, I guess. I did not mean to click on that, but, yeah, we see Cape of up to over 1,000. Areas with over 1,000, Cape, Louisiana, Arkansas, where we could be seeing the majority of the severe weather, but, of course, it could extend past that. If we look at bulk shear, which is very important, bulk shear of 40 and 50 knots are like borderline severe weather usually, but of course they can happen before, they can happen below that still, and above it, it's very good for severe weather, of course, with other ingredients. So we see the it's 5th, we see a high amount of bulk shear of over 100 knots, widespread over 80 knots, which is that red. So that red and yellow, so over 80 and over knots of bulk shear and 100 knots and over of bulk shear are really going to help with this severe weather, especially you see going through Arkansas, Louisiana, combined with that Cape, dew points, and the trough being strongest there. Now, that even with all of these, tornadoes is still looking like only a secondary threat for this, though, but definitely something to watch. If we look at supercell composite, which, there we go. We see up to 10 supercell composite for Texas, and then those blue supercell composites are really when you start to get those good thunderstorms. So, yeah, Louisiana, Arkansas, East Texas, due to this supercell composite parameter, really have to be watching out. That's when you start to have those severe weather potential. And then if we look at storm relative helicity, which is basically these pockets of rotation in the atmosphere, which we will load up here, we do see there's a good helicity. Most of the helicity stays north, but of course, with other factors, helicity is basically meaningless if you don't have the other factors. Lapse rates, which can help a bit with hail. And helicity, like I said, pockets of rotation in the atmosphere, which other tornadic factors can help form tornadoes. So yeah, a good lapse rates, but because they're displaced from most other factors, hail usually isn't a big threat along the Gulf and near it, and it doesn't seem like it'll be a huge threat. If this happens again, take this with a grain of salt. And the final thing I want to look at is 850 MB winds, which we will load up here. Okay, so we do see 25th, 26th, high 850 MB winds. We see that line there. That kind of shows the squall line, QCLS. So there might be significant severe damaging winds, which is over hurricane force, you can see here. But it's a little hard to tell, but because usually they can minorly show wind gusts, but definitely if there is like damaging wind gusts, they will be lower than this amount. So probably regular damaging wind gusts, but still those are bad. But yeah, we'll have to watch out for that. And again, like I said, take a grain of salt. So yeah, guys, that is basically the video. Of course, we got supercell composite, which this blue is is when you really start to get the severe weather, that blue and above. So yeah, we definitely do have that. Of course, you can have severe weather without that, but when you're looking in the long range, that's really necessary. So yeah, we do see that there. And then, of course, you got these high amounts of bulk shear, which you don't see too often. So with surface-based cape, regular cape, while it's not the most unstable, it can definitely help. And yeah, we do have some cape there, but of course, this most unstable cape is definitely present, over 1,000 joules per kilogram. So yeah, anyway, sorry for any bad parts of this video. If you guys have any questions, you could have put it in the chat in the premiere, or you can put in the comments after the premiere, or either way. But anyway, guys, I hope you enjoyed this video, and I'll see you guys tomorrow. Goodbye.